Well, welcome back. Thanks for joining us again. We're the Algebra 2 PLC, and we are about to embark on SLT 22 of the Unit 2 Topic 3 curriculum. So let's see what's going on. I'm John Chase.
And I'm James Key, and we're here on the set of Homework Hotline Live, digging into SLT 22. Let's go ahead and take a look. One of the opening activities in this SLT involves a video in which students will watch the operation of, believe it or not, an automatic butter sprayer. And as weird as that sounds, that could be a really useful tool if you're at a restaurant, maybe perhaps at a hotel, where you're serving dozens upon dozens of pieces of buttered toast. So having an efficient way to get the butter on the toast could actually be really useful. So as you see in this image here, there's a device that can be used to spray the butter directly onto the bread. And if the butter were spreading on a little more thickly than you wanted, you could take that cutting board and place it further away from the butter sprayer, and then you'd be getting a thinner layer of butter on each slice of bread. And our goal, of course, within this SLT is to look at the mathematics of that situation. And in particular, what can we say about the relationship between the distance between the bread and the butter sprayer as it relates to the thickness of the butter on the bread. Now, John, someone who didn't know better might think, you know what, if I set that bread twice as far away from the butter spreader, then it's going to spread on half as thick, right?
I'm afraid that's incorrect. Well, we're going to see, and this next graphic kind of makes this clear, that that's actually not the case. We have a pretty picture here that shows this. The first picture is of the butter sprayer and doing exactly what you just said. That is, here we're at some distance, unlabeled, and now we're at a distance twice as far away. And you can see the picture is like the proof right there that we're actually hitting 4 pieces of bread with the same amount of butter. So that's interesting. And then does that carry on? How does that factor in if we triple the distance? Again, a misconception might be that that we get triple the amount, but it's actually that we get a third of the amount, but it's actually a ninth of the amount. Can we explain that? Well, again, the picture kind of says it. And the second picture is actually not a butter sprayer. What is that? It's blue spray paint, it says there in the picture. And does this make sense for blue spray paint too? Sure. And in fact, actually, there are lots of things. For anything that emanates out from a certain source, an inverse square law will apply. So whether that's electric charge or gravitation or any number of physical laws also that you may or may not know, it might be a great time to consult your science colleague.
Absolutely. Great suggestion. Just in looking at this, ultimately these situations are going to get modeled with equations that have the form y equals some constant number k divided by x squared. So some questions to bring out with your students. What is the constant in the situation involving the butter sprayer? What's the constant involved in the situation involving the spray paint? What are the 2 variables that are involved, and how are those variables related? Lots of good things to think about here. As we continue on with that SLT, another thing that students do is to compare the graph of y equals 1 over x, which we looked at in SLT 21, with the graph of y equals 1 over x squared. So John, do you just want to comment on some of the features of those 2 graphs and a comparison of those features?
Yeah, so we definitely want to ask students again about some of the symmetries that they see in these 2 graphs. I think that's the big one that jumps out at me is, can we use the words like odd or even with these 2 graphs? Can we think about rates of change here too, as certainly both have a vertical and a horizontal asymptote, but for instance, as x grows large, y does go toward 0, true, but at what speed? Like when will the y value be 100? On both graphs? I think we'll find maybe a surprising answer, and that would be a good thing to set before your students too. Is there a difference in the speed at which 1 over x squared approaches the x-axis as we compare it to 1 over x?
All right, as we maintain our focus on standards, let's go ahead and look at this standard from the domain around interpreting functions. This is one of the plus standards, and it involves graphing rational functions. There's a mention of zeros, there's a mention of asymptotes, there's a mention of factorization, and there's a mention of end behavior. As we mentioned earlier in our overview of this topic, there is much more to the topic of rational functions than what we're digging into here. We're really just scratching the surface. And so the material where perhaps multiple asymptotes are involved and where a factorization might be necessary to do the analysis, here we're really just focused on these simple rational functions. And so we really just want students to be able to identify the asymptotes, describe the end behavior, describe some of the symmetries, and that really is the extent of this SLT. We hope that this overview of SLT 22 is helpful to you in your planning. Coming up in the next segment, we're going to take a look at SLT 23. Thanks for joining us.